Hi, my name is Ramna. My personal blog is .netiq.com. If you want to receive my latest videos on your Facebook wall, please go to the .netiq.com. Right side you see a Facebook like button. If you click on like button, you will start getting my latest videos. And coming to today's topic, IDisposable pattern. Before we go to the IDisposable pattern, we will discuss about the finalize, what is the finalize, destructor, and then we'll come to the IDisposable interface and pattern, and using block and dispose versus finalize. These are the topics I'm going to cover. The first one is the finalize. The finalize, basically we implement the finalize method in our C# class to release the unmanaged resource. I'm stressing one more time. We use the finalize method to release the unmanaged resources. Then what is the unmanaged resources or unmanaged objects and managed objects? The managed objects is the means the classes, the objects you write in .NET languages like C# or VB.NET or any other .NET language. If you implement any classes or component in .NET, that is a managed code. And other means if you implement any component or code, developed code in other than non.NET language like in COM or VB6 or any Windows APIs, we call it as a unmanaged resources. But there is a high possibility in your C# class you might use Windows APIs or COM components, or means there is a possibility of using the unmanaged objects, unmanaged resources in your C# class. So once you're done using of the unmanaged resources, you need to clean up the unmanaged resources, means release the unmanaged resources. The cleanup and releasing of the unmanaged resources we do in finalize method. We will implement the finalize method in the C# class to clean up the or to release the unmanaged resources. Remember, if your class is not using any unmanaged resources, forget about the finalize. If your class is using, then start implement the finalize. Yeah, then coming to, is it the finalize is a method? Basically, finalize method, we are saying that finalize method we will write implement in a C# class. We cannot directly call the finalize method. Like in C# means in your class, if you have any method, public method or any method, you can directly call the object instance dot that method. But finalize we cannot call. We don't have any control. Basically, it does not have any access like public or private. We cannot define that, and we cannot call that using the object instance. Then who is going to call the finalize method? The finalize method is going to call by the garbage collector. I'm going to show that. Yeah. Before we go to here, like we know that garbage collector, how it works. Like for example, when the object first time the object creates, the object is going to sit in the generation 0. Then the garbage collector frequently check the generation 0. Is there any object is inactive? Is there any object is inactive? If it object is inactive, so no one is using, then immediately it's going to release and deallocate the memory. The same way, suppose when the garbage collector is checking that object is inactive or active, that time it sees that object header and it finds that that object has a finalize method. Immediately it is going to move that object into from here to finalize queue. Basically, this is the finalize queue. The entire thing is the finalize queue. Garbage collector will maintain a finalize queue. Whenever garbage collector finds that this object has a finalize method is implemented, immediately the garbage collector is going to move that object into finalize queue. So we know that the garbage collector will check frequently the generation 0 bucket, and it is going to means immediately whenever it finds the inactive, it is going to release that object. Then when the garbage collector is going to check the finalize queue to release the inactive object, that we don't know. The frequency is also is very means compared to the generation 0 checking frequency, the checking of the finalize queue frequency is very less. That means that it checks very lately. So even you are done with your object, means your object is inactive or you are no more using the unmanaged resources, but still your object is existed inside the finalize queue. it's not releasing immediately. That means that unnecessarily some memory is going to stay in your heap, and it's going to waste the memory, and it's going to impact the CPU also. So remember, if you have a finalize implemented, that object you don't have a control. We don't know when it is going to release, when it is going to release the unmanaged resource also. That is the challenge with the finalize method. Then coming to how we implement the finalize, I'm going to show that. See this finalize, and one more important thing is there is no finalize keyword directly. You can write implement the finalize and write the cleanup of your unmanaged resource. How we define the finalize is by defining the destructor. You can define the finalize method. Then this is the time to discuss about the what is the destructor. We know that we have a constructor for every class. The constructor we use to initialize your object. That means that it means if in your object you are going to use any other object, you will create the instances inside the constructor. If you get any parameters in your constructor, you are going to initialize those some other details. Means we basically use the constructor for initialization. Then the destructor we use to release the unmanaged, like destructor is at the end of the object. It's going to clean up the, means whatever the cleanup you want to, you can put it in the destructor. The destructor basically, again, the destructor, how we define the destructor is just the tilde sign. If you give the tilde sign and in front of the same class name, it's going to treat as a destructor. So the inside the destructor you can write the cleanup code. But the destructor is, when its code is compiled, the destructor is going to convert as a finalize. It is going to override the finalize method, and it's going to convert as a finalize method. So if you are writing the destructor, means make sure it is going to convert as a finalize, and your garbage collector treat this as a finalize, and it's going to add to finalize queue. So make sure you use the destructor whenever you are using the unmanaged resources in your class. I'm going to show you that how it is going to convert into the finalize method. See, we have a class A, and inside we have constructor A constructor and A destructor. Class B, B constructor and B destructor. Class C, C constructor and C destructor. So basically we have three classes. C is inherited B, B is inherited the A class. And I have a reflector, .NET reflector. Inside that I just attached the my exe, C# performance exe. So this is my project, actually C# performance exe. I referred here. If you go to C# see A class, B class, C class. If you click on A class, C class, you see the finalize method. But you didn't see any destructor. Basically, the destructor is overriding the finalize method of the base object. So the destructor is going to convert as the overriding the finalize method. How we define the finalize method, means how we implement the finalize in C# means using the destructor we implement the finalize, and the destructor is going to convert it as a finalize. And coming to the same thing with B also, just I want to make sure it is, yeah, finalize, and A class, see finalize. So we want to see when the destructor is actually calling. As I mentioned, the garbage collector is have a separate treatment for the finalize method objects. So inside the destructor, means we can say it's a finalize. Inside the destructor, we mentioned that destructor B, destructor A, and destructor C. So whenever this destructor call, I want to print that this method is called destructor C. So let's see when it is going, the destructor is going to call. In my program main method, I just created a C class instance, and I'm saying the C object is created, and after that I'm just assigning to the null. That means that I'm not using the C object, just I'm making it as a null, so I'm making it as inactive. That means inactive means it's supposed to be released by garbage collector, but since it has the destructor, let's see when it is going to release that. I'm running this. See this, assign the null object. Object, basically we are destructing the object, but still you are seeing the creating A, creating B, creating C. That means the constructors are called, but you didn't see the destructors are not yet called, because the garbage collector is not yet called the destructors. Like, I mean to say that garbage collector is not yet called the finalize method of those classes. So let's see when it is called. If I'm closing this exe, that time it's going to clear off all the memory by the garbage collector. That is the time it is going to see. It's called the. Let me open it. Open the exe in command prompt. That way we can see that, because otherwise it is going to close. We are not, before we observe that the destructor is called. I'm just clicking the enter. You see the destructor C, destructor B, destructor A. That means that just before closing the application it is calling. So even if the object is inactive, but still garbage collector maintaining the object's memory. And if you want to see in another way, I'm going to show, like, GC.Collect. If this is one of the question frequently they ask, what is the GC.Collect and what it does exactly. The garbage collector, you are saying that collect means you are instructing the garbage collector clear off or deallocate all the memory, deallocate all the inactive objects memory. It's not active objects, remember, you are instructing the garbage collector to clear off all the inactive objects in one shot. So it's basically it's an expensive operation, because it has to go to the GC. You can specify to the generation wise also, you can specify which generation objects you want to clear off. But if you are not specifying, it's going to clear off all the generations objects. Basically it's a very expensive operation, but you are instructing the garbage collector, go ahead and clear off all the inactive objects, deallocate all the inactive objects in one shot. So that means here we know that whenever you assign the C equal to null, that means you are making that object as inactive. So after that, if you call the GC.Collect, it's going to immediately release that, because you are instructing the garbage collector to take it off. So it's going to immediately call the finalize method of those inactive objects. I'm going to show. Just I uncommented this GC.Collect. Let's see how it works. I need to build this because I'm running it from. See, here I have the console.read line. It is actually stopping the cursor to come out. Okay, so I just rebuild it and I'm running here. See, immediately it call the destructor C, destructor B, destructor A, because after the C assigned null, I'm calling the GC.Collect. So it is immediately, once it becomes inactive, it is going to call the, it is going to deallocating all the inactive objects. Immediately it calls. Still the cursor is staying there. Whenever I hit enter, it is coming out. That means that we know that it's already inactive, but garbage collector is waiting, and that means because of its algorithm, it is taking a lot of time to release the finalize objects. Okay. Then coming to the IDisposable interface. Why we need IDisposable interface? We know the problem that garbage collector, we don't know when it is going to clear off the inactive objects which implemented the finalize method. So there is a performance wise issue. It's unnecessarily keeping the inactive objects memory for a long time. So we want to, it's definitely it's not a right way of managing the memory. So then in .NET we have a IDisposable interface. Basically the IDisposable interface, it has only one method called dispose method. So you can use the dispose, means you can use the dispose method for the same purpose to clean up the unmanaged resources. So whenever you are done with using the unmanaged resources, then you can straight away go ahead and call the dispose method. I'm going to show how we implement that. See, this is another example. I taken the disp example is the disposable example. Basically it has a new class, and we implemented the IDisposable interface. If you want to see what it has is, it has only one dispose method. So I implemented the dispose method over here. This is my dispose method. Then if you implement the dispose method, but that means that you have a control. When you want to, whenever you feel that this is the right time to call the dispose of, means clear of the unmanaged resources, you can call it. That means that it's the user, whoever using that class, is his responsibility to clear the unmanaged resources. If you only rely on the dispose method, and if you write cleanup everything in the dispose method, then there is a possibility, if suppose if the user forgot to call the dispose method, then what's going to happen? There is a chance. So even I create an instance and I call what are the methods I want. I will, after that, if I forgot to call the dispose method, that's it. Means the unmanaged resources won't never clear, right? It's going to be caused to memory leaks. So there is a possibility for the accidents. So then that's why I implemented the even finalize method. Like I have the finalize method, and I also implement the IDisposable interface. So what I'm doing here is just a simple tricky logic. Whenever the user forgot to call the dispose method, that time my finalize is going to be activate. Suppose if user calls the dispose method, I don't want to finalize to be activate. To work that logic, we need to specify in the dispose method. Suppose if user call this dispose method, internally I'm instructing that garbage collector, I'm saying the garbage collector suppress the finalize. Suppress the finalize for this object, this particular object, where I'm saying that suppress the finalize. That means immediately it is going to take it out that object from the finalize queue. Whenever the user call this dispose method, it's immediately going to take out that object from the finalize queue. That way means you are immediately, whenever you are done with the object, you are clearing off your all unmanaged resources, and you are also clearing your object is also becoming released from the memory immediately. That way it's a performance wise, it's going to be very good. And another thing is the as I mentioned, it's IDisposable pattern. Basically this dispose method, IDisposable interface implementation, we can use not only for the releasing the unmanaged resource, you can use for dispose method for releasing the managed objects also, managed types or managed objects. You can use the dispose method for both the purpose. Then we need some kind of separation. So because we don't want to duplicate the logic, so we want to have only one dispose method which is going to call by the finalize method and as well as dispose method. I'm going to show that. Rather, see, I taken a disposed. I define a disposed variable. As I mentioned it as a false, and this is the actual method, the IDisposable interface dispose method. Internally, I'm calling the dispose and passing the true. That means, let's see, we have another dispose method which has one parameter. It's expecting as one parameter, input parameter. So this is the one method. It's a user defined method. Internally, it means it's expecting a boolean as input parameter. Whenever if you pass the true, means basically the dispose method is passing the true. This means that this is the disposing variable. Whenever it is true, I am using this particular if condition to clean up the managed objects. So basically the disposed is initially it is false because when we define it, basically it's a disposed is a false, and we have two conditions. Here we have two conditions. One is the disposed. Very first time it is going to be false. So who is going to call this one is the matter. Suppose if it is dispose is going to trigger user call the dispose method, then we are passing the dispose to true also. Where initially it is false, so this condition is going to satisfy. And once immediately satisfied, since it is called by the dispose, if you want to write any managed code cleanup, you can write here. And after that you are saying that dispose is equal to true. So as I mentioned earlier, if it is called by the dispose method, you are already specified that GC.suppressfinalize. So the finalize method is never going to be called, means it's never going to be triggered by the garbage collector. For example, user forgot to call the dispose method. You are saying that here call the dispose and you are passing as a false. That means that why you are passing the false is we know that the finalize method we use only to release the unmanaged resources. So basically finalize method won't care about the releasing of the managed resources. So you are passing the false. So first step is going to be satisfied because no one is called the dispose yet. So it's going to be false and satisfied. The second step is going to be the disposing. Since it is false, this block is not going to be executed and it is going to be disposed. Then after that is going to be disposed true. Basically this is the place after the if condition you are going to write to clean the unmanaged resources. So if you following this pattern means we can make sure that you are providing the option to user, as well as you have a backup option for the garbage collector going to take care in any case if user forgot to call the dispose method. And one more thing is, in .NET we have a using block. Using block means yeah, before I discuss about the using block, just I want to, whatever the sample we implemented, I want to execute this. I'm just here I'm calling the example, created a instance for this class, and I'm just calling the greeting method, and I'm specifying this null. I'm not calling the, I just commented the dispose method calling, so I'm not calling the dispose method. And let's see. So the object is still because you are not calling the dispose, so the object will be remain there, because dispose has the suppress finalize. So we are not calling the suppress finalize, so the garbage collector will treat this as this object has the finalize method, so it's going to hold it. I'm just rebuilding this, and I'm calling from this. See, you see here, dispose object created hello Ramna, and assign the null, but the destructor is not yet called. If you just hit here inside the finalize, that means that the garbage collector, because you are closing the exe, so the garbage collector called the finalize method of that object. So you see, even you have to implement the dispose, but you forgot to call the dispose, it's going to use that backup of finalize. Now if I call this dispose method, see the hello Ramna and assign null object destructing, you assign the null. So that means that you call the dispose, by this time object is inactive, and also the object is released from the garbage collector. If I hit enter, you see you didn't see any statement from the finalize. Earlier you see this inside the finalize, now you didn't see any statement from the finalize. That means destructor is going to dispose is going to taken care of releasing the unmanaged resource. Dispose is suppress the finalize also. Okay, and so to avoid the accidents, so like calling of the dispose, maybe sometimes you maybe forget, so the .NET they introduced the using block. So if you put the using key, like parenthesis here, and after this you don't need to call this, and see. So if you create your object instance, which is the object which is implemented the IDisposable interface, so using block you can create, if you create the object instance, it's going to automatically take care of calling your dispose method. So the end of the block, it is going to call your dispose method. Basically it is going to take care of calling your dispose method of that object. Let's see. Sorry, I am going to recompile this. I just recompiled it. Now let's see. So the object means assigned, then it's going. You see, you didn't call the finalize method. So make sure if any class has the dispose method, try to create that class instance using the using block. In .NET framework itself, we have so many classes, like DB connection. The connection object, basically connection is a unmanaged resource. All the SQL connection, OLDB connection, ODBC DB connection, all this connection has a dispose method. Before you create any object, just make sure it has any dispose method is implemented. If any dispose method is implemented, go ahead and create that instance using the using block. See here, I have one more example. I created the SQL connection instance using the using block, because SQL connection object has the dispose method. That dispose method is using to release the DB connection. DB connection basically it's an unmanaged resource. So the best practice is to make sure if you are using any .NET framework classes or any classes, if the class has the dispose method, create the instance of the class using the using block. If you forget using the using block, make sure you need to call the dispose method explicitly. That way you avoid the GC finalize queue, like memory deallocation. So that way your performance wise also it's very good. Okay, and coming to the last slide of this, yeah, few of the bullet points. Use the using statement in C# to ensure dispose is called. Yeah, as I mentioned, make sure if any class has the dispose method, use the using block to call that in class, create the class instance. Do not implement the finalize unless it's required. Means if you, that means that if you really, if your class has a unmanaged resources, then only use the finalize. Otherwise, don't use that. And if you implement the finalize, don't forget to implement the IDisposable. So if you damn sure, the thumb rule is if you implement the finalize, you make sure you implement the IDisposable also. Because most of the time user will call the dispose method. In any case it means we have a backup option, the finalize method, and suppress the finalize means, yeah, as I mentioned, in your dispense method, make sure you suppress the finalize method. If you have a finalize is implemented in the class, make sure you suppress the finalize method. And means if you have any thread safe type, if means your class is a thread safe type, better to use the lock to dispose, means dispose also use the lock to releasing and take care of the thread safe issues. I hope I covered the what are the topics we started. And next time I will come up with another interesting topic. Thank you.